Hey guys, it's Miss Vinson. Today we're going to talk about one of the underlying most important topics of the firm, and that is productivity. So first, let's think back to the circular flow model and remember where firms were. Firms were sellers in the product market, but they were the buyers in the resource market. Well, that's because firms couldn't make goods and services out of thin air. They had to have those factors of production: land, labor, capital, and entrepreneurship. So let's talk about some of those resources. Now, we can divide those resources into two broad categories: fixed and variable resources. Fixed resources are things that you cannot change very quickly or easily. So some examples of fixed resources might be like your store space or your factory size. So fixed resources are things that you're kind of stuck with. Variable resources, on the other hand, are things that you could rather quickly or easily get more of or get less of or change them out. Really, guys, from this point forward, when you start to hear variable, I really want you to start to think labor. Labor is the most variable resource. How? Well, if I wanted to have more workers, I could interview them and tell them to show up tomorrow, and I could add 5 more workers to my labor force. But if I wanted to have a lower labor force, I could fire some workers and tell them never show up again. So I could very quickly or easily change the number of people that I have working for me. So labor is like the ultimate variable resource. Now, not only are businesses going to use fixed and variable resources, but they're also going to operate on 2 different time levels. They're going to have a plan for the short run, but they're also going to have a plan for the long run. The short run is a shorter period of time. It's not a specific period of time, but it's a shorter period of time where you have at least one resource that you're stuck with. So technically speaking, the short run is a period of time where there's at least one fixed resource. The long run is a period of time where nothing is fixed and everything is variable. So in the long run, you can think about it, nothing's set in stone. That's so far in the future that nothing is fixed. So everything is variable in the long run. Now, a lot of times businesses will have a short run plan and a long run plan. They'll have short run goals and long run goals. So a business might say, in the short run, with the amount of factory space that we have and the number of pieces of equipment that we have, our production goal is 600 units. But in the long run, maybe we can build another factory and get more machines. And so maybe in the long run, we hope to produce 3,000 units. Now let's imagine that we are a factory and we're operating in the short run. Let's say that we have a factory that's making jeans. Well, some of the fixed resources that we might have at this jeans company could be like our factory size or the number of sewing machines or other pieces of equipment that we might have. So suppose we have some of these fixed resources. We have just a certain amount and it's not easy to get more. Well, the variable resource in our factory example is going to be our workers. Suppose I have nobody working at my factory. Well, if I have nobody working at my factory, then nothing is being produced. Well, let's hire some more people and let's keep track of the production levels of our workers. So I'm going to have a chart, and as we hire more people, we're going to have a column that keeps up with the number of people we have working for us. We're also going to have a column that keeps track of the extra stuff that's produced from the new workers, and we're also going to have a column that keeps track of the overall total output. Now, this chart should look a little familiar to you. Do you remember talking about pizza and noodles? Remember how we had a chart that kept track of the number of slices of pizza you ate, the extra satisfaction from each additional slice, and the overall satisfaction? Well, this is the exact same chart, but instead of noodles and pizza, we're talking about blue jeans and workers. Well, let's get into our example. Suppose we hire the first worker, and so he's the only one working. So one person by themselves might not be super productive because they have to do all of the jobs on their own. So when we hire this first worker, maybe they're only able to create 10 pairs of jeans, but let's give them a little bit of help. Let's hire a second worker. Now, when we hire a second worker, notice that these 2 workers are going to be able to specialize and divvy up the jobs. This second worker has added an additional 15 units of output. Now, when we hire this third worker, they're joining the team to try to help. Well, they're not able to contribute as much as the second worker, I guess because maybe they didn't have as many tools to use. So now when we add that extra 11, our overall total output is 36. Now, when we hire a fourth worker, this fourth worker maybe can't really contribute that much because they don't have a lot of tools, there's not a lot of jobs for them to do. So this fourth worker can only really contribute 10. Well, let's just keep hiring people, all right? Let's say that we hire a fifth worker, but when we hire them, they can only contribute an extra 9. Are they not as good as the workers that we hired before them? Well, maybe so, but that's not necessarily true. Things are getting pretty crowded now. We have 5 workers and we don't have that many machines and tools. So everybody's kind of getting in each other's way. So that fifth worker gave us an extra 9 to make our overall total output go up to 55. Now let's finish out this chart. We're going to hire a 6th worker, a 7th worker, and then we're going to hire an 8th worker. And look at what's happening. Every time we hire another worker to this factory, we're just putting another person into the mix without adding the tools, without giving them any extra jobs to do, without giving them any extra equipment. So it's almost like we have this situation where there's too many cooks in the kitchen, right? We have all these people crowded around and they want to work and I'm paying them a salary to work, but they just there's nothing for them to use and nothing for them to do. So maybe the 6th worker can only add an additional 8 and that makes our total go up to 63. We'll take a look at that 7th worker. They're not able to contribute anything extra. Maybe there literally was nothing for them to do or nothing for them to use, so they were just standing around. And then with that 8th worker, notice that they didn't add more. Actually, that 8th worker kind of took away from our total output. Maybe they just started knocking things over and messing things up, and they knocked over a whole thing of jeans and ruined them. Our 8th worker's contribution was a -3. So now our overall total output's down to 60. So look at the columns that we have in this chart. These are our productivity terms. First, we have the number of workers we have working for us. That is our labor. We abbreviate that with L. The extra stuff added by hiring a new worker is called marginal product, or sometimes some books call it marginal physical product or marginal productivity. So notice how we were talking about the contribution added when we hired each additional worker. That's marginal productivity. And then we had our overall total output. Now our overall total output is going to be represented by Q. The reason why it's represented by Q is because it's referring to the entire quantity of output that's being produced by our entire labor force. So this is our total output. Now let me point out a relationship here. Everything we learned about marginal and total in utility still applies. Notice that as long as we're adding a positive number to our total, as long as our marginal numbers are positive, our total numbers are going to increase. When we have a negative marginal number, our total numbers are going to decrease. And so marginal is still the slope of total, and total is still maximized when marginal is at 0. And remember how we had diminishing marginal utility? Well, we have something similar, but it's called the law of diminishing marginal returns. Diminishing marginal returns says that as you add more and more workers to a stock of fixed resources, productivity might increase at first, but eventually if you keep adding those variable resources, those workers to those fixed resources, things are going to get crowded, things are going to get chaotic, and productivity is eventually going to fall. Now there's one last term that we need to add on this chart that we didn't have on the utility chart, and that is average productivity or average physical product. Some books call it different things. How do you find this? You're just going to be doing the average. Your average productivity tells you how much stuff is being made by one typical worker. Guys, this is like what I would do if I were finding a class average on a test. So when I want to find a class average, I'm going to add all of those test numbers together and get a total, like this big grand total score, and then I'm going to divide that by the number of students in the class. Well, if I'm trying to figure out how productive one average worker is in that factory, then I'm going to get my overall total output, which is our Q, right? And we're going to divide that by the number of workers we have, which is our labor. So when we do 10 divided by 1, obviously that first person, they're just making 10. On average, they're making 10. When we have 2 workers and together they're making a total of 25, then on average, each one of those workers is making about 12.5 units per person. When we have 3 workers, then on average, each one of those 3 workers is making about 12 units per person. When we have 4 workers and together they're making 46, on average, each one of those 4 workers is making about 11.5 units per person. When we have 5 workers, collectively making a grand total of 55, on average, each one of those 5 workers is making about 11 units per person. When we have 6 workers and together they're making 63 units, then on average, each one of those 6 workers is making 10.5 units. Then, when we have 7 workers and they're only making 63 units together, then on average, each one of those workers is only making 9. Then when we have 8 workers, then on average, each one of those workers is only making 7.5 units per person. Man, kind of sounds like adding those extra people was sort of dragging down our production average, right? Well, that brings us to a couple of key relationships. First, let's talk about one you're already familiar with. That's the marginal total relationship. We just talked about that with utility. We just mentioned that a second ago. That hasn't changed. It's just marginal is the slope of total. In fact, if we wanted to sketch these production curves on a graph, they're going to look exactly like the utility curves that we've already seen. So when we sketch our marginal productivity curve, when we start hiring our first couple workers, our productivity really goes high. And then as we keep hiring extra workers, the marginal productivity falls. We have diminishing marginal productivity, and eventually it can go negative whenever we hire somebody and they knock things over. But now that we have average productivity, let's talk about the marginal average relationship. This also is something that you're probably very familiar with. In your senior year, you know that you can exempt your final exams for that semester if you have an average of 80 or higher, and other qualifications. So when it comes time at the end of the semester, I have a lot of students that are always keeping an eye on their grade, and they're checking out how each new assignment affects their average. So maybe your average in a class is an 80. Maybe it's Spanish, all right? And so your average is right there on the edge. It's an 80. So if you make a 100 on the next test grade, on that next Spanish test, muy bien, then what is that 100 going to do to your average when you add it in? It's going to pull your average up, right? And so that next test grade is kind of like a marginal thing, right? It's something extra or additional. So if the next thing is higher than the average, it's going to pull your average up. What if your average in a class was an 80 and on your next test grade, let's say you just weren't feeling this unit in Spanish and you made a 30? That's really bad. What's that 30 going to do to your overall average? When you add that in, guys, that's going to pull your average down. So we have this marginal average relationship. Marginal pulls average around. If the next thing is higher than the average, it pulls your average up. If the next thing is lower than your average, it pulls your average down. On a graph, we can really see this. We're going to put our average productivity curve on the same graph as our marginal productivity curve. And so it's going to start at 0, same thing as your marginal productivity, but since it's an average, it's not going to go as high or as low. It's just going to be a little bit even, but it is going to increase and decrease. So your average productivity curve is going to increase, and as long as marginal is higher than your average, it's just going to keep pulling your average up. Even when your marginal is falling, if your marginal is still above your average, it's still going to pull it up. Like your test grades, 100 will pull up an 80, but wouldn't a 90 still pull up an 80? And wouldn't an 85 still pull up an 80? So even if the next thing is getting lower, as long as it's higher than the average, it's still going to pull your average up. If your marginal starts to slice and go below your average curve, that's going to start dragging your average down. So our average curve is going to start to turn and fall down. So we're going to work with some more charts in class, and we're going to also practice graphing this and reading the graph in class so you feel more comfortable with it. But if you get this, then this really sets the stage for some of the cost terms and later profit information that we're going to learn about that's so important to firms. Alrighty guys, until later, I'll see ya.